Hey there, and welcome to a continued dialogue about how we graph trig functions. And in this video, we're going to talk a little bit about what the different transformations do to the graph of y equals sine of t. And we're going to start picking apart some of the functions and really kind of understanding what each of those pieces does. So when we're looking at the equation for the graph of a sine function, our a, b, c, and d are the different kinds of transformations that might occur to our parent function of y equals sine of t. And we really need to know what all of these things does to the graph so that we can graph it appropriately. So let's start by talking about amplitude. Amplitude, remember, is going to be the distance from the center or the midline to the maximum, which means since it's distance, it will always be positive. And a vertical stretch or shrink is going to affect that, right? We're going to represent amplitude as the absolute value of A. Now, if I'm thinking about period, the length of the period or the full cycle of the sinusoidal curve, right? Our parent function is going to, the period will be 2 pi, and so a horizontal stretch or shrink will affect the period. So we will think about the period of a transform function as 2 pi divided by b, and period will also always be positive. Now your phase shift is a horizontal shift. Okay, this is going to take your graph and shift it left or right. And we are going to find what that phase shift is by taking C and dividing it by B and making it negative. And that will show us the direction of the shift as well as the distance that it shifts. And the last thing is probably the easiest thing because it is exactly the same as our regular transformations. Our vertical shifts are represented by D. So a vertical shift of D will shift something up D units. And then if it was negative here or subtraction, we would shift our sinusoidal function down D units. So let's take a look at this table. And this table has 4 different functions of sine that have been transformed. And we are going to pull the appropriate pieces from the functions here. So we're going to identify what's going on. So remember, so let's look at this first function right here. Y is equal to 3 times the sine of the quantity t plus pi over 4. And that whole thing will be added to 3. So our amplitude will be the absolute value of this coefficient here. So our amplitude is going to be the absolute value of 3, which of course is 3. And then the period will be 2 pi divided by b, and b is the coefficient to t. And in this case, t has a coefficient of 1, so our period will be 2 pi over 1, which we know to be 2 pi. Our phase shift will be negative c over b. So c is pi over 4, and it's divided by b, which is 1. So we have negative pi over 4 over 1, which is negative pi over 4, which means this will shift pi over 4 units to the left. And then our vertical shift, this plus 3, is telling us we are going to shift this whole function up 3 units. Okay, so let's try this next one. The function that we're looking at here is y is equal to negative 1/2 sine of 6 pi t minus 7. So here, our amplitude will be the absolute value of this coefficient of sine, so the absolute value of negative 1/2, which will give us 1/2 as our amplitude. The period will be 2 pi divided by b, which is a coefficient of t. So 2 pi divided by 6 pi, which will give us a period of 1/3. Now our phase shift will be negative c over b. Now notice that there is no c here because there's nothing inside the sine function with this 6 pi t. So there is no phase shift, and our vertical shift is the remaining constant here, this -7, which is going to shift this function 7 units down. All right, we're going to do this last one together, and then I'd like you to try the very last one on your own. Okay, I'm going to give you time to do that. So amplitude here. The absolute value of this coefficient will be the absolute value of -5, which is 5. Our period will be 2 pi divided by the coefficient of t, so 2 pi divided by 4, which is pi over 2. Our phase shift will be negative pi over 2 divided by 4. Okay, and so that is actually positive pi over 2 divided by 4, which is pi over 2 multiplied by 1/4, which is pi over 8. Now that tells us we're shifting pi over 8 units to the right. And then our last shift that we're worried about is vertical shift, which will be up 2 units. Okay, take a second and pause the video and see if you can come up with the transformations of this very last function. All right, welcome back. And let's go through these, and we're going to do it kind of quickly. The amplitude will be the absolute value of 2, which is 2. The period will be 2 pi divided by 1/4. Now 2 pi divided by 1/4 will actually end up being 8 pi because you're going to end up multiplying 2 pi by 4 over 1. Okay, now our phase shift will be negative pi over 1/4. So that will be positive pi times 4, which is 4 pi, or 4 pi units to the right. And lastly, our vertical shift will be down 5 units.